So in the next proof, we start with the same premises. Actually, we have the same three premises as in example 4, but we want to derive a different conclusion. This time we want to derive for all x if px, then qx. And so what we'll do is we'll start with the same base proof and then just erase some of these steps to see what we can get, if we can get the other conclusion to follow. So we'll go through and try and see what we can do. So same assumptions, but now notice that I have a universally bound conditional statement as the conclusion. This means that at some point in the proof, I'm going to have to hypothesize the antecedent, derive the consequent, and then put a universal quantifier out front. Now I'm going to try and do that inside of the subproof that allows me to do existential elimination, like in the previous problem. So let's go ahead and put in our hypothesis for existential elimination. So RAA, say, and then we'll go ahead and put in the hypothesis for the conditional that is the conclusion we want to derive. So I switched to A's here because I want to put PB in my hypothesis for the conclusion. Okay, so in this subproof, I want to show QB. So what can I do? Well, if I have PB and I know I have RAA, I can instantiate this universal again, so I can get RAA arrows MA by eliminating the universal on line 1. On the next line, I can get MA since I have RAA. So you'll notice that this is very similar to the proof for the previous problem. So I eliminate the conditional on line 6 with line 4. Once I have MA, I can say exists x mx. And the reason I'm going to do that is because I want to get the antecedent of this conditional statement on line 3. So introduce an existential on line 7. Once I have that, I can get the consequent of that, which is for all y, qy, by eliminating the conditional on lines 3 with line 8. If I have for all y, qy, I know that I can instantiate it with a b. So I can say qb. And it doesn't matter here that B is used in the assumption for the subproof because this is a universal instantiation. Which means that if I have PB, then I have QB. Now the next thing is that I want to do a universal introduction on line 11. So I want to say for all x, if px, then qx. The way that I do this is by just introducing a universal, but I need to make sure that B doesn't occur in any open assumptions. And it doesn't, so we're outside of this subproof in which we used B, which means B doesn't occur in any open assumption, so we're allowed to introduce the universal there. So for the next line, what we'll say is that if you hypothesize RAA for all x, px arrows qx, by introducing the arrow again. And then the final step of the proof. So we have on line 2 that there exists something such that our ZZ holds, and then we have if RAA, then this conclusion. So by an existential elimination, I can actually just get that conclusion. Now note here that I need to check whether A occurs in any open assumptions, and it doesn't because we're outside of this entire subproof. So we're okay. And it doesn't occur in the premises, so that's good. And it doesn't occur in the original existentially bound statement or the conclusion, so we should be okay. So now I'll type this all into Carnap. And just to not make you sit through me typing, here it is, and we get the green check from Carnap.